All right. So yeah, let's talk about bridges and kind of connect that to how the blockchain world in general, how various chains in various ecosystems can talk to each other, what the problems are, what new solutions are, and kind of how we can see the future. So let's start with a short round of introductions.
Okay. My name is Dong Song. I'm a professor in computer science at UC Berkeley and also the co-director of a new campus-wide center called the Berkeley Center for Responsible Decentralized Intelligence, focuses on decentralization technologies and so on, and also the founder at Oasis Labs.
Hey everyone, GM. I'm Rahul. I'm one of the co-founders of Connext. So Connext is an interoperability protocol. We built one of the first bridges to XDAI actually before it was Gnosis chain. So we've been working with the ecosystem for a very long time. We've just released our latest bridge, which of course still supports XDAI and Gnosis chain. And we're very excited to be part of the ecosystem.
Hey, I'm Phillipp. I'm one of the founders of Li.Fi. We are a bridge and DEX aggregation protocol. Have been the first bridge aggregator. Connext has actually incubated us, so we're at the forefront of watching that space and how it's evolving, and we have already implemented the new bridge, Amarok, which is developed by Connext. Having a good overview about the bridging landscape overall, what's happening, what's to come next, and happy to be here.
Cool. So we want to talk about trustless bridges, but let's start with the situation today. Let's describe the situation of bridges today, and maybe also kind of what are the problems, maybe for each of you.
So in general, we have a very fragmented bridging environment, I would say. So in general, maybe let's talk about the different kinds of bridges. Real quick, we have arbitrary data messaging bridges maxing out on generalization. So layer 0, Axelar, Wormhole, Nomad, we have heard of in Hyperlane. Those are these A and Bs. On top of that, because message verifications are expensive, we have liquidity networks. So instead of minting and burning, we lock in release funds on multiple chains. Here we have Connext, for example. We have FOB, C-Bridge, multi-chain, a bunch of others. Then we have ecosystem bridges. So each ecosystem wants to remain independent from third parties. So if Optimism the Optimism Gateway, Polygon's POS bridge, and so on, they can mint and burn. They are fairly centralized, but the ecosystem would also, of course, cover any issues that come up, and they can do large trades, most often just in one direction. Going back is a 7 days withdrawal time, so that's why going back we would use a liquidity network. On top of that, we have the stable coins releasing their own bridges. They're going to eradicate a bunch of these liquidity networks. We have around 50 liquidity networks out there. So USDC is releasing their own stablecoin bridge, centralized due to regulatory circumstances. DAI is utilizing Maker's Relay network and working with Gelato on their own DAI bridge. So here again, a different type of bridge. And then we see the first NFT bridges coming up, and we see zero knowledge proof bridges. So sometimes I just need a proof. Let's say I'm an Arbitrum. I want to have proof that this is my lens profile on Polygon. Then I can use a zero knowledge proof bridge like Lagrange or Herodotus or Saxon.
Let's maybe start with the bottom,
Sorry.
kind of the I mean it's
just
great,
want to give an overview.
Right. So let's start with the lowest layer of bridges, those that try to be most general, and try to bridge arbitrary messages. What are the different approaches we have seen so far?
I think one really important thing to note here is that each of these bridges have very different trust models and trust assumptions. And I think that's kind of where the crux of this talk is going to get to, because from the outside looking in, they all have very similar interfaces, they do very similar things, but really the underlying approach to trustless and trust minimization is very, very different. So you have these ways that you can bridge, which is like external verification. So that's where you have an external set of actors that is verifying that something happened from one chain to another chain. But in that, what you end up doing is you lose the trust of the chain itself, and all your trust ends up going to the bridge validators themselves, which of course is like a big problem, because when you're using a blockchain, you want to just be able to trust the blockchain. So we've tried now, and like there are various teams, like Phillipp mentioned, that are doing kind of different things to approach this verification problem. Like one approach that Connext uses is we use like an optimistic verification model on top of the bridge messaging layer itself. So, no matter what, we can always use a decentralized set of watcher actors to make sure that no fraud or any kind of corruption happens on the base validator layer itself. And then we can basically sit this verification one level higher. And then, of course, then you can get to like validity proof based bridges. And that's where you get to really interesting things because, I think the end game for bridges at the messaging layer is going to be this kind of like validity proof based system where you get the best of both worlds, where you get kind of instant bridging, but you don't lose the trustless properties of the bridge. Of the chains, sorry.
Right. Okay, great. Yes, so going back, talking about the problems with today's bridge solution, I think the earlier panelists already mentioned a few things, and trust definitely is a big issue, and that's why we are doing like Ziki Bridge and so on. And another thing I wanted to briefly mention also is, I think in the bridging world, it's moving in the right direction, but at least the earlier ones, like they are very monolithic. So I want to talk about this extensibility for developers. So because the interface the bridge exposes actually is at a higher level, so that in general, the bridge actually itself does a lot of things, does token swap, does like, but it actually doesn't expose enough of the lower level interfaces. So that's the other issue. Later on, I'll talk about Ziki Bridge too, is that really it's about providing also a truly trustless, permissionless base layer that actually, in this case, provides this API that it's easy for developers to then actually build on top. And on top of that, you can build messaging, you can do NFT transference, swapping, and so on. So it's really easy for developers to further extend the functionality. So I think in the bridge world, like the bridge term itself is actually very overloaded. So we want to actually talk about the base layer and then things building on top. So at the base layer, really here, it's about, for example, you actually expose the block header from another chain, and then once you have that basically becomes your roots of trust, or roots of validity, then you can build other applications on top. And that's today's many functionalities of what Bridges provides.
Maybe you can speak to that and kind of just give an overview. I mean, you are dealing with all those bridges. Just roughly give us an overview of how they might be different, or kind of how many there are, and so on.
I touched base on the different types, right? And we can use an existing model that has actually been primed by Connext, which is the interoperability trilemma. So essentially, all of these bridges are taking 2 out of 3 trade-offs. So we have trustlessness, where we are asking who is verifying the system and what would it take it to corrupt it, right? Here we have externally verified bridges, natively verified, locally verified, and optimistically verified ones. Then we have generalizability, layer 0, Axla, and so on are maxing out on that. So what we are asking the question, what can you do with it? Kind of everything. But therefore it's often much more trusted, or it's not that extensible. And that's actually the third factor, extensibility. How easy is it for a system to expand, to, for example, leave the EVM space and go to Solana, go to somewhere else? And all of these bridges are taking different trade-offs. It's really hard to get all the 3 things right. And that's problematic. And we see different players having different approaches. We saw bridges starting very decentralizable, and then they FOMO'd out on other players that were gaining market share in a very fast pace, for example, multi-chain, and they changed their mindset, became much more centralized, and executed much more aggressively.
I would say, I would maybe even add kind of to this trilemma, maybe there's even another dimension is simply cost. So kind of gas cost or transaction cost, which might be sometimes in conflict with decentralization, or at least, I mean, like if you just have one player you 100% trust, then that's probably can be even the cheapest.
Yeah, absolutely, and I can add to that too, because at Connext we kind of maxed out on decentralization, and what we use is we send like underlying message layers, like we use the Gnosis A and B to send routes between Gnosis and Ethereum. So then what we end up doing is we gas costs, where we send these routes every like 30 seconds through the bridge. That ends up being really expensive, but we are trading that off right now because we want to preserve the aspects of decentralization, trust minimization.
And I want to throw in, because it fits right now, I want to throw in another factor here. The cost and also the speed that we have to trade off for decentralization are really a problem. We are talking to traditional finance a lot these days, and these companies are like, we can't use bridges or DEXs because they are too slow. We are used to if we want to make a $100 million trade, we need nanosecond performance and not millisecond performance. And with bridging, we are talking minutes performance right now. Right, we are so far away from having the ability to actually onboard traditional finance, and bridges are just strengthening this issue.
Yes, I'd like to add to the point of cost. I think in this case, actually being truly trustless, permissionless, and decentralized, it actually can really help reducing costs. Because otherwise, when you actually have to trust like a small committee or whatever, then your operation cost is actually very, very high. So, for example, what happened to Ronan, what happened to Harmony, and so on, like
100%. I mean, if you include those costs of losing 600 million, then
I mean that's a part of it, and also for future bridges, if they want to like a community-based bridges and so on, and that's right, basically not fully trustless or trust minimized. So for them to avoid those issues, what it means is that they have to put in like a huge amount of resources for their security, to improve their security posture, and that will actually incur huge operation costs. So when you have truly trustless, permissionless bridge solutions, then that part of the cost is zero. You still have to audit, your ZK circuits and so on. So those you still have to audit, but at least you don't have issues.
yeah.
But I'm actually curious how much the ZK costs become in that sense. Like, are the transactions very expensive to prove the ZK circuits on chain?
So you can do, you can do batching, aggregation, so you do amortize the cost, right?
Cool. Then let's move on to the topic of trustless bridges. So maybe to frame that, I think in Ethereum, bridges were kind of an afterthought. So kind of Ethereum started, and then independent of Ethereum, other EVM chains emerged, but kind of while that happened, the chains were not kind of designed immediately thinking of bridges. So kind of essentially then bridges were added later to it. I think in another ecosystem, in the Cosmos ecosystem, that was slightly different. So there, the idea of bridges was a central component. So maybe one of you can, kind of just describe how it can look like if bridges are deeper integrated.
Well, I think one point is that Ethereum already does have trustless bridges in the case of rollups. So rollup bridges are, I believe, the most trustless form of bridging possible. And I think, if you get into that thing, then you can really see that there is already this thing. Yeah, there's no standardization around protocols. They've all implemented it differently. But I think you do have the most trustless thing. But then when you step outside of that, then, of course, you add that extra trust assumption as well. But I think one interesting thing we see also is these bridges, like the Polygon POS bridge, for example, and I think the Gnosis AMB bridge also does this, where the validators of the chain are running the bridge also. So then you basically trust the bridge as much as you trust the chain. And if you use those systems, you actually do preserve the trustlessness of the chain itself.
Yeah. So maybe just to kind of double down on that. It seems now possible to while previously you would need a smaller committee. It seems now, or well, not just it seems, we know it's possible to have bridges that fully validate the consensus of other chains. Maybe you can.
So right, I think certainly that's one possibility. So the goal is really you want to achieve what's called this light clients, verification and so on. So certainly, each validator in the chain can do that, and then altogether, then they can provide that level of validity checks and so on. But one thing I want to say, comparing to the ZK the ZK version of this, essentially, the goal is the same. And you are trying to actually prove the same things. It's just in one case, so the validators, they actually have to run, essentially, the full like-line verification. But in the other case, they can just, you just need to do this simple verification of the ZK proof. So what the ZK proof does here is that it can actually significantly reduce the amount of work. Otherwise, especially when you have many chains, then the validator actually gets very busy because the validator then has to validate each other, right, for the bridge to each other chains, and actually has to run these like lines essentially for all these different chains. So that actually can be more work for the validators. But when you actually compact this using ZK proofs, then the work gets, again, right, gets amortized, so then you actually have much less work for the validators to do in that case.
Maybe to add to this, while natively verified, so like client-based verification is the most trustless way to do things, the reality is that it's not only Ethereum that's relevant, it's probably also Cosmos these days that's relevant, and we have seen Solana being very relevant for a long time and probably will come back, we'll see. But I think the whole nature of things, right, that we are pouring lots of research, like just getting it on a macro level, like we are pouring a lot of money into research in terms of DLTs and cryptography, and all these new findings have to be productized. We're going to see new L1s, like we see with Aptos Suicide. So there will be a continuous thing to happen, and we need to find ways not only for users, but also for businesses to actually not be that affected by trends and being reliable businesses on top of this multi-chain environment. So the question is, can we move forward with light client-based bridges? It's going to be hard. I think Wormhole is pivoting in that direction, that they actually want to tackle this. They can do that with 160 employees, but it is like the trade-off here is extensibility. So you can only solve that by throwing more money at it and more people. And then again, you create a bunch of tech debt because, like, if it means that we have to implement light clients on each other's chains when they are not compatible with each other, that's just very tough. Also, IBC is reinventing itself all over again. Here and there, we see new people building new products in the same direction. So Polymer actually working on ZK IBC, for example. So we also see innovation in that space. But all in all, yeah, there is to say it's very early, and we need to solve this bridging problem.
So one thing I would like to add is, I'll talk a little more in my lunch talk as well. So basically, we are hoping that, just like you said, initially when the L1s or even L2 or whatever, like when they were designed, they didn't really think through about the bridging aspects. But going forward, we hope that every chain, when they design, they actually will have this in mind. And even better, we want to help each chain to become what we call ZK friendly. So basically, it makes it easy for them to produce ZK-based light client proofs. Then in that case, each chain, they only need to do this, and then the other chains, then they can just run these simple verifiers, then it'll be much easier. So the integration will be much easier.
You're touching a very important topic, standardization, right? Maybe Martin, you made a proposal for a multi-bridge abstraction. Maybe you can talk about that.
Yeah, for sure. Stepping out of the role of the moderator. We as a chain are affected by this problem that there are 2,700 bridges that all have different interfaces. So yes, the one proposal we are, with actually many people, or with on people on the panel putting forward is to say we should try to separate things that have trust assumptions from the rest, because then it will very likely be much easier to agree on standards if trust assumptions are not involved. So the idea is to say we have those we have light clients. I would say ideally zero knowledge based ones, but you have sources to get a block header from another chain, and ideally it actually is light client verification, but as the space is very heterogeneous, possibly also still committee based or whatever, but anyhow, you have different sources and you agree on just a block header of another chain, because that really contains, or that really is kind of the core of the bridge, of the bridging task. And then, of course, well, applications don't care about the block header, they care about a specific message or a specific token. But you are separating here this core task of getting the core information from the other chain. And there you can also nicely aggregate. So, I mean, it's just insane how much funds have been lost in bridge hacks. It's really, really sad. And with this approach, we could have what we call additive security, or you
call it defense in depth.
Right. And say, okay, if there's a new bridge coming up, it can add to the security, and not, you say, instead of saying you either take this approach or that approach, because obviously there's also the trade-off between security assumptions that might be better in a zero knowledge based proof, but technology risk might be, well, lower in a multisig. So the idea would be, okay, you can actually have those multiple sources and have them all agree on a block header, and if they all agree, fine. Then you can accept that header. If one source disagrees, well, then you can have very trust minimized governance. So the governance cannot do anything unless kind of there's a conflict in the bridge, and then then you need the governance, and then it's of course much better to have governance step in compared to have a loss. That is a proposal we are together pushing forward, and the hope is of course that this will lead towards having at least then all the layers on top more standardized, and I think the hope is that eventually you can sit on one chain and natively call a contract, or kind of almost abstract the fact away that a contract you're calling sits on another chain. But I think that's still a long way to go.
The problem here is also that bridges are not the biggest fans of standardization, right? Because once you standardize interfaces, the lock-in effects are heavily reduced, switching codes are reduced. It's much easier to just replace the existing system based on changing incentives. Then again, maybe not the right guy is winning. But if you want to enforce standardization, it's probably up to the ecosystems to work together and enforce bridges to act in that way and enforce standardization. I think it has to come from the ecosystems.
This standardization is kind of at like the lower level. I think, like you were saying, right? You separate it down to the lowest layer, so each bridge can still preserve their like top level user-facing interface, but at the bottom layer, kind of implement these controls. I really like this idea, by the way, and I think this is where we need to go.
There's another standardization proposal by Open Zeppelin. I have forgotten which EIP it is, but there is a second that does it on a higher level.
I've seen multiple of these standards come out, like standards for cross-chain message calling, but like things like that are also being implemented by each bridge separately, and each bridge is going to say, well, if we win, then ours becomes the standard. So
right. So over lunch I'll talk about the ZK Collective. So the hope is that the ZK Collective really it's a community building to bring the community together to then again, right? It's much easier to standardize at the base layer. And that's the goal, is to actually provide this, we call it secure universal foundation for multi-chain interoperability.
I would certainly say we should go beyond to standardizing the base layer and say kind of we also standardize.
One step at a time.
100%. I mean, that's absolutely the requirement. If you haven't standardized the base layer, you can't do stuff above. I would say we should do stuff above, but I do agree.
It's going to get spicy.
It will be. There will be open questions about kind of the economics and what parts are kind of quote unquote commoditized and what parts are actually kind of business models. So maybe just a prediction on
that
topic.
That's another really interesting point, is that we kind of have broken up the bridging into multiple layers. So you have like the base layer of like messaging, transport, verification, and we think that is the most likely to get commoditized into something that looks like a public good, because that's really what it is meant to be. I mean, you can't really monetize that much, so it really should be developed as a public good and standardized and given to the community. Whereas, I think where bridges can really separate and differentiate themselves is more at these top layers, where they have a much easier interface. They have like the liquidity like layers. They have things like this that kind of can lock in users, bring in a community, build a community around, rather than the base level infrastructure, which should remain as neutral and trustless as possible.
And you are smiling because you are sitting exactly there at the top layer.
Because you're absolutely right. And at the very same time, we see just movements not in the right direction. We see larger DEXs starting to negotiate kickbacks with that lowest layer, where we need the money, like the fee that's been taken by bridges, we need that for decentralizing these systems. And if a Sushi, for example, or others are starting to take that fee from these validators, we won't be able to decentralize these systems further. And so they're using their demand power, like their traffic power now, to negotiate kickback fees. Li.Fi could do that too, but we absolutely agree with you. We shouldn't do that, but it's difficult because it becomes a race to the bottom here again, and that's really dangerous for decentralization.
And they actually should contribute to the public good. I mean, the Zk Collective, the goal is to build public good, and they should actually contribute to this public good.
I maybe want to add one more kind of new thought why I think this bridge standardization is so crucial, and that is another hot topic we have seen currently here at ETHDenver is account abstraction, which I absolutely believe is absolutely key for the whole ecosystem to develop further, and that is the idea that your identity is not just a single key, but some form of likely a smart contract, or essentially it can be richer and it can have additional rules. That is great and that is coming, but that has one big problem, and that is that is simply a key. If you have a simple EUA key that you have in a way automatically on multiple networks, but such a richer account, a smart contract account, you only have on one chain. And if that account has state, so kind of like, let's say a set of owner or recovery or something like that, then then it's crucial to have bridges. Otherwise you will have separated identities on many chains. So kind of it would, like, we hope, I think, that we will have recovery mechanisms, but if you would need to have a recovery mechanism and set up, I don't know, kind of a social recovery or some form on every chain individually, I think that's an absolutely no go, or that simply won't fly. So in my view, what we need is you have an identity on a chain, but you can still do things on other chain, but that means the bridge needs to be as standardized and as secure that it can actually kind of transport your identity to other chains.
Yeah. I think there are more problems coming up with it. It's also then about, in order to get a zero knowledge proof of a certain state, I need to be aware of what do I want to prove. So I can't make assumptions. I need the information on another's chain, like what is existence. Right now, these things are living in the client by having the wallet there, but will that be the future? We don't know. Then also it's about maybe redundancy. Maybe we want to have some data redundance and not having my identity, like everything that's tied to it, living on just one chain. Maybe I want to have a copy of that somewhere else, and then that has to be orchestrated somehow. It's a very interesting, very important research topic for sure.
I mean, it's already so crazy. Like, the UX is so horrible. My co-founder Arjun literally lost 10 ETH because he bridged from his multi-sig, his safe on one chain, to the same address on another chain, and didn't realize that it's just poofed there. So it's crazy how bad the UX is around that, even for people who are like crypto native. So this is a very important thing that you guys are talking about here.
can we? Wondering if we can end on a more happy note. So, what's your positive outlook? Okay, so let's
lost to deflation.
Yeah, ultrasound. Yeah. So then maybe let's end with kind of your vision or your kind of maybe of each of you, your positive outlook for the future.
I would say my positive outlook is that we are aware of these topics, not only us here on the panel, people are working on it, right? We are very early, so I'm just very bullish about the fact that we are trying to figure it out as an industry, and we see so much collaboration around these things. I think on that topic of around account abstraction, we saw heavily involved was Biconomy as a bridge provider, Alchemy as an RPC provider, Open Zeppelin as someone like priming standardization in the space, and so on. So we see collaboration around these things, and I think these challenges are those who are bringing us together much closer than we were before. So that's what the positive outlook on this.
Yeah, I would say like the fact that people actually care about this stuff. You know, people are like trying to actively push back against these centralizing forces and actually caring about building these trustless public goods based base layers. You know, like what you're doing is like really amazing, I think, because it's going to set up this future for a world where we can actually have trustless bridging and don't need to trust intermediaries.
And we have a community effort to really have the community come together to build this public goods. And that's what I'll talk about over lunch as well. So we have now a hackathon. Actually, right, Gnosis Builder is supporting it too. The ZKP hackathon, one of the tracks is ZK Bridge, where we bring the community together to actually, through this hackathon, to also help build this ZK Bridge. And so essentially, right, so you talk about the future. So the future, I do hope that we can have this future where using ZK technologies and together with others to really build this truly trustless, permissionless, secure, and universal foundation for multi-chain interoperability. And also that actually provides, on top of that, you can really have a very powerful programming abstraction to truly enable multi-chain applications.
Thank you so much.
So I think we have actually 10 minutes for questions.
Thank you. This is super insightful. I'd love to invite you to develop more on the idea of public good and standardization. It seems like there's some parallel dynamics between TradFi and DeFi. You know, the banks it used to be super expensive to send money across the banks as well. But I guess in 1973 or something, 240 banks across 50 countries got together and created this thing called SWIFT. And today we process like $700 trillion of money. Seems to be working okay, but obviously it's like, you know, super CeFi, right? So we don't want that. So like, what can we learn from like TradFi for a common protocol that's like working? And is there anything we can learn?
I would say one problem, and that's also was the major problem with bridge hacks. If we look closely, it was not about bridge design that went wrong, right? It was about a huge demand meeting immature tech and a race to the market. So people had immature DevOps setups. They have immature tech in general because, and that's the nature of tech. It's just immature because you know, like edge cases come up over time, right? So what can we learn is essentially, I think we need these bear markets actually. We need these bear markets to wash out what's not working, and then we need louder voices in that standardization topic. Like the outcry for standardization is simply not loud enough, right? And we see there is a group called Chain Agnostic Improvement Proposals. We haven't touched base on that yet, right, in this conversation here. But they are working on standardization heavily, and it starts by, okay, how should an account ID look like? How should a blockchain ID look like? That's why we need to start with naming things in an organized fashion, and then from there on we can grow tech in an organized fashion and interfaces and whatever.
So that's a good point on the naming. So I think addresses probably should evolve because right now if you share an address or at least in the Ethereum space you share an address, then it's not clear on, or it doesn't contain any information about the chain. And yeah, then of course those mistakes can happen, that you are actually, well, you receive funds on a chain where this address even doesn't belong to you.
And maybe we can also create an incentive system around standardization. I feel that's also somehow missing, that people are not incentivized enough. And it's probably, maybe it needs a central instance that works decentralized, but a central instance that thinks further about standardization and creates an incentive system, and then we onboard system by system. Like Gnosis is very open to that, I know, right? But let's get more system into that direction. I can also see, for example, there are so many L1s that have zero adoption. All of them would be interested in standardization, right? It's only those who already have a mode. They're not interested in giving it away. So let's start the other way around. But once you have an army of 100 L1s complying with standards, like it will somehow, like it will derail traction from existing L1s and then flip the situation.
And I think you see things like the biggest standard wins, like EVM is now a de facto standard because it's won and got so much traction.
Yeah.
And also I hope that things in this decentralized world will be much easier than in TradFi, for example, because here I think being open, like you can see everything how it works and you can see the code, whereas in TradFi, like everything is proprietary, it's closed system, it's a lot harder.
I mean that's a very good point. So I mean we can build those standards to chains or even around bridges without even asking them.
Yes,
essentially.
right, exactly.
Or
right, that's why.
getting their permission essentially. Yeah.
Right.
And actually, just to tie it back to his question about public goods, I think if we approach this problem as building public goods and not building companies, because when you build a protocol, you're not building a company, you're building a public good, then you're going to build some kind of like DAO to govern it. And that's really how these things need to be built. Like you said, they need to be built in the open. They need to get everyone on board. So they need standardization up front. And if you design all this stuff with that up front and not try to build a closed moat that you can just use to like, you know, get yourself market share, then you can actually like develop a system which will be inherently more secure, inherently more safe, inherently more open, inherently cheaper, because you have enough people like working on these optimization problems together.
So right, that's why we hope everyone can join the ZK Collective to really build the community together. But one thing I do want to mention is that one thing we've already seen is when you have this type of public goods, like everyone tries to, you know, we hope that everyone can work together to build the public goods, then there's a question about tragic of commons. Then nobody actually wants to actually chip in and do the work and so on. So that we have already seen.
It's the Moloch problem, right?
Unfortunately, so I think right there is some question about the incentivization. I think it is important to figure out good incentivization mechanisms and self-sustainability mechanisms for these type of public good building.
Cool.
Awesome. Well, thank you guys.
Thank you.